In section 7.1, we derived a sample size formula for n that tells us how big a sample we should take if we have a desired width for our interval, and this formula depended on the fact that we knew the value of sigma. If we do not know sigma and we replace sigma with s, the sample standard deviation, we still have the same formula for n. The one catch here is that if I'm trying to figure out how big a sample to take, I may not have taken a sample yet, and in that case, I won't have a value of s because s is a sample standard deviation. If you have an adequate guess for s, you can use it. Another option is to replace s with this other guess for what s might look like, which is, what do you expect the range of your data to be divided by 4? So in the example 7.2.2, we have that the sample size of 53 initially resulted in a maximum lead content of 42.34 and a minimum of 21.12. The range then is the difference in those. If we divide that by 4, we get a decent guess as to what S would be in this larger sample. And so what we get for this value is about 5.305. If I want a width then for a 90% confidence interval of 1.5, I want a W of 1.5, and our Z for a 90% is 1.645. So our formula looks like n equal to 2 times 1.645 times our 5.305 guess for S divided by our desired width of 1.5, and we square that whole thing. That will give us 135.38. And remember, we always round up when talking about sample size, so this answer would be that we need a sample of 136 children. One thing I have in here as a note is that if we would do this procedure and maybe get something small like, 22, we get an answer of 22. Remember that everything we're doing here does require us to have an n of at least 40 so that we can be relaxing the normality assumption and using s in the first place. So if you would get a small answer for your n like 22, you would need to bump it up to be greater than 40, so we would need a sample of at least 41 in that case.